Welcome to another episode of CockroachDB Bytes. Today we're going to be talking about surviving two simultaneous region failures. First of all, sorry for the mess. My standing desk stopped going up and down, which is really frustrating for me. I had to replace the whole frame and everything. Good news is it is working again, but I still need to kind of clean up the mess in the back. So today's topic is surviving two simultaneous region failures. So we've talked before about CockroachDB's ability to withstand different types of failures. So out of the box, we can survive a single node failure given a cluster of at least 3 nodes, and also what we call an availability or zone failure, which is really refers to the notion of an availability zone. And availability zones for cloud providers are generally within a region. You'll have multiple availability zones, and they're separate, like discrete, maybe buildings that are located close to each other that have their own power supply and networking, and are designed to be, not connected to each other from the sense of, failure of a certain type in one will cause a failure in another. So yeah, you can think about them maybe as just like separate buildings that are kind of within a couple miles of each other. So different failure domains for the cloud providers within a single region. I think the key to availability zones is they're separated by a very small amount of network latency, typically maybe 1 to 2 milliseconds. So they're very close to each other. And when you deploy a CockroachDB cluster, either be a cloud provider on your own or through a managed service, even if you just pick a 3-node cluster, you should be deploying it within a region to 3 different availability zones. So if one of those availability zones becomes unavailable, then the cluster will continue to function. And when we say to continue to function, and we talk about survivability, we're talking about it can serve reads and writes. Nothing's happened to your data. You haven't lost any data. You may have reduced the number of resources in your cluster, but as soon as you bring up another node, join it into the cluster, it can rebalance, and everything's fine. Don't have to worry about it. So by default, CockroachDB ships with zone survivability. One zone goes down, you can survive it. But a lot of folks really want region survivability, because region survivability is the second type of really easy to configure survivability. Region survivability is the ability to survive an entire region going down. So obviously you can't just have one region, but you have to have 3 regions, and that goes to CockroachDB and consensus protocol and write quorum. So we need the majority of things to survive, nodes to survive, voting replicas to survive if something goes down. So if an entire region goes down and we've done the right thing in configuring where our voting replicas are across regions, then we will have the majority still running. That might change the latency characteristics of your application. When it goes down, you might now need to serve all of your traffic with 2/3 of the resources until you scale up, but it's going to continue serving reads and writes. You're not going to lose any data with region survivability. So the big difference with zone versus region survivability has to do with the number of voters and where they're located. So in zone survivability, we have 3 voters, and that's the default configuration. So every range, we talked about ranges, slice of data has 3 different copies of it. It's called replicas. One is the leaseholder, and there's 3 voting replicas total, and 1 in each availability zone. So availability zone goes down, we still have 2 out of 3 voters. So for zone survivability, we need to go to 5 voters. So what that looks like is we spread the voters out across 3 regions in a 2-2-1 configuration. So if any single one of those regions goes down, we'll still have 3 out of 5 voters running. Reads and writes can serve, everything's going well. Like I said, you have fewer resources until you scale up. You might have different latency characteristics depending on where your application's running and where your leaseholders are, but cluster's still going to be working and survive and all those good things. So the question is, what about surviving two simultaneous region failures? That's not super well documented in the official documentation. Honestly, there's not a lot of users and customers that need to survive two regions. But the reality is that there are critical use cases that for one reason or another need to survive two region failures. It may be that, for the cloud providers, region failures are not very common, and two simultaneous region failures, I would wonder if that's actually ever happened before with a cloud provider in recent time. But we're not always working with cloud providers, and there's different resiliency characteristics that we need. So if we want to move to be able to support two simultaneous region failures, we're going to need 5 regions minimum. So let's think about the number of voters. Okay, so let's say we have 5 regions, and we had region survival previously configured, so we have 5 voting replicas. Well, we could actually do two simultaneous region failures on 5 voting replicas across 5 regions, and here's how it would work. You would have 1 voting replica in each region. So 2 regions go down, now you still have 3 out of 5. Sounds great, right? It sounds really simple. So 5 is entirely achievable. Now the problem arises if you have any leaseholder preference to your data. If you have your data geo-partitioned, maybe on a database level you have a primary region and your leaseholders are in that region, or maybe you have some regional by row tables, so you have data partitioned in a way that's geo-partitioned and geolocated. So if you only have 1 node in each region, 1 voting replica in each region, well, what happens if the node that voting replica is on needs to be has a sudden failure, or maybe you need to do an upgrade, a minor or major upgrade, or anything else that requires maintenance, or just a rolling restart, right? So as soon as that node goes down, that lease is going to jump to another region. So for some cases that might be okay. Maybe I don't really care. Maybe I'm not very latency sensitive. But for most cases, if we specify a leaseholder preference, if I want the leaseholder to be in this region, then we want it to stay in the region whenever possible. In that case, we're going to need more than 1 replica in a region. So let's consider the 7 voting replica case. Maybe that would work. So if we had 5 regions, 7 voting replicas, then we would have 2 in one region, 2 voting replicas in another region, and then so for 4 total voting replicas, and then 1 voting replica in each of the remaining regions. Sounds pretty good, especially if I've constrained my leaseholders to the region that has more voting replicas. Problem with that, though, is that if 2 regions go down, it could be the 2 that have the 2 voting replicas, right? We could lose 4 voting replicas at once. Losing 4 out of 7 only leaves us 3 remaining voting replicas. Not good. That's not going to achieve quorum. You're going to have unavailability of ranges. You're not going to be able to serve read and writes. So 7 voting replicas is actually not a valid configuration for 2 simultaneous region failures. So let's try 9. So what would it look like with 9? So if we did 9, what we could do is put 2 voting replicas in 4 out of the 5 regions, and then 1 voting replica in the remaining region. If any 2 regions go down, the most voting replicas that we could lose would be 4. So we would still have 5 voting replicas. Better yet, if we always have 2 voting replicas in the region where we have the leaseholder constraint, we can, as soon as something happens to the node that's a leaseholder, maybe it's a rolling restart, it's a node failure, whatever, that can get transferred within region, and we're going to keep the same latency characteristics during that restart, or whatever node issue we might be experiencing. So 9 voting replicas gives us that ability to transfer leases within region, and that's really critical. I mean, I would say there's probably very few people who don't need to be able to have a transfer within region. The other thing is that for load-based lease transfers, we can also balance load within region easily with 2 voting replicas. We can just do a lease transfer. Lease transfers are really inexpensive. Up replication, where we're creating a brand new voting replica, is much more expensive because we have to snapshot the data, we have to transfer that, it takes network, takes CPU, etc. So yeah, so I would say for the most part, you're going to say go with 9 voting replicas for that configuration. Now, you may be familiar with the multi-region SQL declaratives, where you can say alter database, add region, set primary region, survive region failure, all those things, or region survival, and all those things. Those are not going to give you the 2 region failure and 9 voting replicas. In 22.2, I believe you could achieve it with zone configuration extensions. And if I would recommend that approach. And as a final fallback, you can do manual zone configuration setup for the 2 region simultaneous failure situation. So before we wrap and I give a recap, I want to talk about one other aspect of this, and that's system tables. So CockroachDB has a number of system tables and ranges that are used for the just normal functioning of the cluster. They are essential. You have to have a quorum on those for the cluster to be functioning normally. So if you say show all zone configurations in the SQL client, you'll get a list of all your zone configurations, and you'll see a number of system-related zone configurations in there. And one thing you'll probably notice right away is that the number of voting replicas for those system ranges is actually 5 by default, and that's, you spin up a cluster, it's always going to default to 5 and try to achieve 5. So going back to my original point, when we started talking about 2 region failure, is it's possible to survive 2 simultaneous region failures with 5 voting replicas. Particularly if you don't have any lease preferences set, then that might be sufficient for you. So system tables are one of those cases where they don't have specific lease preferences. So it's probably okay to just leave your system tables at 5 voting replicas and have that be a 1 in each of the 5 regions, 1 voting replica in each of the 5 regions, and not try to increase it to 9. Now, there's nothing wrong with going to 9 if you want to increase resiliency in the cluster, but you can survive 2 simultaneous region failures with respect to the system tables if you just leave it at the default 5 voter configuration. So to recap, I'll say you can survive 2 region failures with 5 voting replicas, but most users for user data are going to have some lease preferences defined and are going to want to keep those lease preferences during a node failure or rolling restart or some other event that affects the node, a single node. So for that reason, I would always recommend using 9 voting replicas across 5 regions for a 2 simultaneous region failure. As far as systems go, you're probably okay just leaving the default. If you want higher resiliency, you can change system tables to be 9 voting replicas as well. That's my CockroachDB Bytes segment on surviving 2 simultaneous region failures in just under 15 minutes. Hope you enjoyed it, and have a great day.